Question for exam 2. This is multiple choice short answer. Show work for partial credit. Part A. Terminal speed is defined as choice 3, the speed at which the drag force cancels the gravitational force. The gravitational force is acting down, and the drag force is acting up, and they're balanced when the object is at its terminal speed. Question 2, part B. An object of mass m is hanging by a string from the ceiling of an elevator. The elevator is moving upward but slowing down. What is the tension in the string? So if we draw a free body diagram, here's the body object of mass m, and it has a vertical component upward of the tension force and its weight acting down. The velocity, they say, is upward, and it's slowing down, so the acceleration must be in the opposite direction, which must mean that there is a net force downward, which must mean that mg is greater than the tension force. So the correct answer is the tension is less than mg. In part C, when a car goes around a circular curve on a level road, assuming the car does not slip, which of the following is true? Well, as we noted in the previous question, here's the car going into the page, and it has S of S acting on it, and it's equal to mv squared over r. If the speed increases, then the frictional force increases, as long as it doesn't slip. So the correct answer is choice 2. In D, we have 3 parts. Determine the following for the figure on the right. Assume the box starts at the top of the inclined plane and is accelerating down the rough plane. The kinetic coefficient of friction between the box and the surface is mu sub k. The first part of part D asks you to clearly identify all the forces acting on the box. You can do this by drawing on the diagram of the box. Well, we have the x component of the weight acting down. If this is the x direction. And we have kinetic friction acting up. We have the normal force acting in this direction. And we have the weight acting vertically down, and it has a y component opposite the normal force equal to mg, or f sub g, y. If you had on your exam, you had to show that there was an x component of the weight acting on it Well, no, I didn't. I gave you full credit if you showed the normal force acting in the direction shown, F sub k in the direction shown, and Fg acting vertically down. If you simply did those three, then I gave you full credit. In the second part of the problem, draw the free body diagram of the box on the axis provided to the right. It's actually below. Break up any vectors into components so that all the forces are either on the axis of motion or perpendicular to it. So if I call the x direction the axis of motion, then I have F sub k acting in this direction, and mg sine theta acting in this direction. And it should be drawn bigger than F sub k because it is accelerating down the incline. It's sliding down the incline, so in the direction perpendicular to the direction of motion, they must balance out. So mg cosine theta acting downward should balance the normal force acting upward, or in the plus y direction, not upward, but in the plus y direction. I hope this is clear. If it's not, you should email me or see me during office hours. And then the third part of D says, describe each force identified in the first part, part I, that will influence the acceleration. If they do not influence acceleration, please say so. Well, the weight and F sub k definitely influence the acceleration because the net force acting in the x direction is equal to F sub k minus mg sine theta. And that's equal to m times a. F sub k is equal to mu sub k times F sub n. So indirectly, the amount of the normal force affects the kinetic friction, which affects the acceleration. So only indirectly. I will take this answer just alone, or I will take this answer plus this answer with a description of why the normal force influences the acceleration in the way it does. And that concludes this question for exam 2.